Today we like to look at surface areas of cuboids and then its volume as well. Now, a cuboid, an example of a cuboid is this box that you are seeing over here. Looking at this cuboid, this is the depth or the height. Now, this is the length. This is the length. There's the length. There's the length. And then this side is the breadth. So for us to find the surface area of this cuboid is the same as to say that we want to find the total surface area of this cuboid. We can see that each face is a rectangle. So clearly this is a rectangle, this also a rectangle, this is a rectangle, and then the top two is a rectangle. One thing that we are supposed to note is that the area of this front side is the same as the area of this very side. And then the area also of this side is the same as the area of the back two. It's the same thing, the same area. And then the area of the top is the same as the area of the base. So how do we demonstrate this? Now let's go to the board and then let's demonstrate it very well. So as we said, there's the length, there's the height, is the same as this, which is the height, is the same as this one, two, which is the height, is the same as this one, two, which is also the height. This is the length, this is the length, the back to this is the length, this also the length. Now for us to find our total surface area, we know that each face is a rectangle. How do you find the rectangle? Length times breadth. So in this case, we can see that we have the length and then the height. So this face, we have L each. And this side is the same as the other one too at the back, as I demonstrated. So it's the same as plus L each. Then let's also come to the side. Let's also come to this side. Now, how do you find this? We can say that B times H, the area of finding this rectangle. So that is B times H. And the same as the other one too over here. So another B times H. Now, what is the last one that is left? Now, I want to find the base. So the base, we can say LB. So plus L times B. But it's the same as the top one. So you see plus LB. Now, what can we see here? LH, LH. That is 2LH. So we have 2LH. Plus, we have BH, BH. That is 2BH. We have LB, LB. That is 2LB. Clearly, what can we see? 2 is common. It's a common factor throughout. So I can factorize the 2 out. So when I factorize the 2 out, I have LH plus BH plus LB. This is the total surface area of a solid cuboid. Let's see carefully. We can see that the L is appearing twice, that is L. Let's see, there's also B which is appearing twice, BB, this B is appearing twice. And then let's see the H, H2 is appearing twice. So in essence, let's suppose that we've been given L, W, H. If we want to come out with the formula, how can we come out with a formula? We will say that the TSA, 2 outside. And we have to make sure that each variable appears twice. So we can say LW plus LH plus, that is LW plus LH plus WH. And let's see if each variable is appearing twice. So W is appearing twice, HH is appearing twice, and then LL is also appearing twice. What about if it is the sides are A, B, C? We want to find the total surface area. Now, the formula is saying that each variable should appear twice. So we can say that here AB plus AC plus BC. And you can see that A is appearing twice, B is appearing twice, and then C is also appearing twice. Let's see this example. A box has length 8 meters. So L, that is 8 meters. The width is 5 meters. And the height is 10 meters. We are being told to find the total surface area. Now, our TSA, a factor of 2 outside as we generated. So here, everything should appear twice. So LW plus LH plus WH. So LW, let's see, L is appearing twice, W is appearing twice, H is also appearing twice. Now, what is our L? Our L is 8. So 8 times 5. L is 8. 8 times 10 plus 5 times 10. 2 outside. What is 8 times 5? That is 40. What is 8 times 10? That is 80. What is 5 times 10? That is 50. 2 outside. Now, what is 40 plus 80? That is 120. 120 plus 50, that is 170. Now, what is 2 times 170? Now, this is 340. And because it is area, we say meters square. Now, let's consider this example. We should calculate the total surface area of a cuboid whose dimensions are, that is 12 centimeters, 8 centimeters, and then 3 centimeters. So we've been given the dimension to be 12 centimeters times 8 centimeters times 3 centimeters. This implies we can say that the L is 12 centimeters. We can say the W is 8 centimeters. And we can see the height is 3 centimeters. Now our total surface area, a factor of 2 outside. Here what can we say? LW plus LH plus WH. All the variables should appear twice. So L is appearing twice, W twice, H is also twice. Now 2. What is our L? We have 12 times 8. What is our L? That is 12. H is 3. What's our W? 8. What is our H? That is 3. Factor of 2 outside. What is 12 times 8? This is 96. What is 12 times 3? This is 36. What is 8 times 3? This will give us 24. Why are we doing this? Board mass, bracket first. Bracket first. So, what is 96 plus 36 plus 24? And this is giving us, that is 156. Now, what is 2 times 156? You can check that on a calculator, which is 312. And because it's area, centimeters square. Find the height of a cuboid whose length is 5. So we want to find the height. We don't know the height, but then we know the length is 5 centimeters. We know the width. The width will be 4 centimeters. And then we also know the total surface area. That's 148 centimeters square. Now, we want to find the height. With this, we know that our total surface area. Now, all variables should appear twice. So you can say that LW plus LH plus WH. Now, all variables should appear twice. So L12, W12, H12. Now, we know the total surface area, which is 148. 2. What is the length? The length is 5. What is the width? The width is 4. What is the length here? The length is 5. Height, we don't know. What's the width? The width is 4. What's the height? We don't know. Now, board mass, bracket first. What is 5 times 4? That is 20. Now, what is 5H plus 4H? This is 9H. We want to find H. We can expand by multiplying through with the 2. So we have 40 plus 18H, 148. 2 times 20, that is 40. 2 times 9H, that is 18H. I want to find H, so I have to group like terms. I have 148 minus 40 equal to 18H. Now, what is 148 minus 40? this is 108 equal to 18h. I want to find h. What should I do? I can divide through by what is multiplying the h, which is 18. So 108 over 18 equal to 18h all over 18. Clearly this 18 will cancel this. 18 will go into 108, that is 6. Therefore the height is 6 centimeters. Now let's see this question. This past question it says that an open rectangular tank is made of a steel of area 1,440 meters square. It says that its length is twice its width. Now we don't know the length, so if we know the width, we'll be able to know the length. So we can say that let x be the width. Therefore, if the x is the width, it means that the length will be 2x. Now it went on further to say that if the depth of the tank is 4 meters less than the width, we should find the length. Now clearly here, let's suppose that this is our length, this is our width, this is our width, and then this is our height. Now we don't know the length, but we've been given a relation. Its length is twice its width. It means that we can say that let the width be x, and if the width is x, therefore the length will be what? 2x. Why? We are being told that its length is twice its width, and then we also being told that its depth, that is the height, the depth that is the height of the tank, is 4 less than the width. Now the height is 4 less than the width. So if the width is x, it means that the height becomes what? X minus 4. That will be the height. Now the question says that it is open, an open rectangular tank, and then the area is 1,440. So they've given us the total surface area, and that is what? 1,440 meters square. Now let's look at it carefully. You are being told that it is open, it is open, it is open. So the top wouldn't be there. If we want to find the area, we know that finding the area is addition of all the total surface area, that is addition of all the areas. So clearly our total surface area, our TSA, clearly. Now the bottom and the top are the same, but it is open, so the top isn't there. Clearly the bottom part will be L times H. It's a rectangle, so we have LW plus. Now let's see, this side is the same as that side, so I can say that 2LH. Why? This side and that side are the same, so it's going to be LH plus LH, but because it's the same, I'll say 2LH plus. Now the other side and then the other side too, they are also what? The same. Remember, this is H, so what can I say? I can say WH, and then another side to WH, so that is 2WH, and I can say this is the same as LW plus 2 out LH plus WH. But then I've been given my total surface area. What is my total surface area? My total, so here, our total surface area, we had it to be, that is LW plus 2 outside, and then we have LH plus WH. Now, our total surface area is 1,440. What is our length? Our length is 2x, so you have 2x. Now, what is the width? The width is giving us x plus 2. What is the length? The length is 2x. Now, what is the height? The height is giving us x minus 4. Now, what is the width? The width is x. What is the height? The height is x minus 4. Now, this becomes 2x squared plus 2. Now, let's expand. This will be 2x squared minus 8x. 2x times 4, that is 8x plus x times x, that is x squared, x times this, that is negative 4x. And we have 2x squared plus 2. Now let's add the brackets. Let's work the one in the bracket first. Board mass, bracket first. So 2x squared plus x squared, this will give us 3x squared. Now, negative 8x minus 4x, that is negative 12x. We have 1,440, 1,440. Now, 1,440, 2x squared. Now, 2 times 3, that is 6x squared. 2 times is negative 24x. Now, clearly, what can we see here? 2x squared plus 6x squared. And this is giving us 8x squared minus 24x. We have 1,400. We want to find x. Clearly, we are seeing that we are getting a quadratic equation. And we have to put it in the form ax squared plus bx plus c equal to 0. So from here, let's take this to this side. So we are going to get 8x squared minus 24x. Now this is on the left hand side, cross and becomes negative 1,440, and then this is equal to 0. Clearly I can divide through by what is multiplying the x squared, 8, because 8 is a factor of 24 and then also of 1,440. So we divide through by 8. And this implies we have 8x squared over 8 minus 24x over 8 minus 1,440 over 8 equal to 0. Now this 8 will cancel that 8. 8 will go into this one. 8 will go into 24. That is 3. 8 will go into itself 1. 8 will go into 1,440. That is 180 times. So in a nutshell, we have x squared minus 3x minus 180 equal to 0. Now, the coefficient of the x squared is 1. We have to factorize this. Now, two numbers, when you multiply, we will get negative 180. The constancy is 1, so 1 times negative 180, that is negative 180. So two numbers, when you multiply, you get negative 180. And when you add, you get negative 3. Now, these values, we can consider negative 15 and then positive 12. So from here, we have x squared minus 15x plus 12x minus 18 equal to 0. Let's see this. You can see s is common, so you can get x minus 15 plus 12 out. X minus 15 equal to 0. Because 12 times 15 will give us 180. Now, from here, x minus 15 is common, so we factorize it out. So x minus 15, we factorize out. And then what is also left? X plus 12. And this is equal to 0. Now, we are multiplying two things equal to 0. What should we do? We use the null factor. Now, if you have two things multiplied equal to 0, we say that x minus 15 equals 0, or x plus 12 equal to 0. So you have x minus 15 equal to 0, or x plus 12 equal to 0. So you have x equal to 15 or s equal to negative 12. Now the question says that if the depth of the is 4 less than the width, we should find the length. Now x is 15 and then x is what? Negative 12. Now x can never be negative. Therefore our x is equal to what? 15. Why is it that the x can never be negative? The x is a width. We know that the width is x, and it can never be what? Negative 12. Now, our L, we know is 2x. X is 15. So that will be 2 times 15. And this is 30 meters. This is 30, because 2 times 15 is 30. Now, the question says that we should find the length. So the length is 30 meters. I believe it is a very easy question. Please, you can play back the video for better understanding. Thank you. Now let's consider this past question. This is July 2009, question number 5. The base of a prism whose height is 12 centimeters is a right-angled triangle with dimension that is 17 centimeters, 15 centimeters, and then 8 centimeters. We should calculate the total surface area of the prism. Now we know that this is a prism and then it is having a uniform cross-section. So all the cross-section will be what? Triangle. It says that a right-angled triangle. Right-angled triangle. It means that the 90 degrees should be there. Now the best thing for you to do first is to try and then sketch the diagram that has been given to you. So this is my sketch. Clearly we can see that this is a triangle, and with a triangle we know the area of a triangle. For triangle, the area of a triangle is half times the base times the height. And because it is a prism, clearly the area over here on top is the same as the area beneath. So if this is 8 centimeters, then this one too is the same thing, 8 centimeters. This 15 centimeters. And then this side too is 17. So here too is what? 17 centimeters. Now the height. This is giving us a 12 centimeters. It means this is also what? 12 centimeters. This side too is also what? 12 centimeters. We want to find the total surface area. That is addition of all the areas. So let's take the triangular part first. So RTSE. Now, I'm bringing a factor of 2. Why factor of 2? I can see a triangle here. I can see another triangle. And then the same side. Now, area of a triangle is half times the base, which is 15, times the height. Look, the height is 8. Now we are done with the two triangles. Now let's see this side. We can see that this is a rectangle. A of a rectangle, that is the length times the breadth. Clearly the length is 12 and then the breadth is 15. We are also done with this. Now let's also come to this side. This side too is a rectangle. What's the length? 12. What's the breadth? That is 8. So plus 12 times 8. Now let's see which side is also left. We are now left with the other side at the back, which we can see. But that side too is a rectangle. So the length, we can see that 17, and then times the length, we can see times the breadth, which is also 12. So that is 17 times 12. Clearly, let's see, these two will cancel that. And then what is 15 times 8? This is giving us 120. Now we have 12 times 15, and this will give us 180. Now what is 8 times 12? That is 96. And then 17 times 12, this will give us 204. You have your calculator, so please make use of the calculator. Clearly we have 120 plus 180 plus 96 plus 204. And this clearly would give us, that is 600 centimeters square. That's how we find the total surface area of a prism. Now let's consider this past question. It says that in the diagram ABCDEF is a triangular prism. That is ABCDEF is a triangular prism. Now it means that all the cross section is the same. So clearly ABC is the same as FED because it is a prism. Now it says that angle ABC, that is ABCDEF, equal to 90 degrees. It means that we can apply the Pythagoras theorem. We are also given that AB is equal to 24, and then BC is 7 centimeters, and CD, that is 40 centimeters. You calculate AC. Clearly, where the AC is, we can get a right angle triangle. So the first one, the AC, let's come out of this right angle triangle. Now on top we have A, this is B, and then this is C, but the angle is 90. Now what is AB? AB is 24 centimeters. What is BC? 7 centimeters. So we can use Pythagoras theorem to find our length AC. What does the Pythagoras theorem say? It says that AC square equal to the square of the other side. So we can see that AB square plus BC square. Now, what is AB? AB is 24, so we have 24 square. What is BC? BC is 7, so that is 7 square. We have AC. Now, you're allowed to use the calculator. Don't waste your time punching this on the calculator. Clearly, the square AC, the square will now become square root. So you have square root, that is 24 square plus 7 square. And when you punch this on the calculator, you are going to get 25 centimeters. That is our AC, the length AC. Now, the second one says that the total surface area of the prism. Now, total surface area, addition of all the faces, the addition of all the areas of the faces. Okay, let's say this side. This is a triangle, and this side is the same as that side. So for us to find the total surface area, first let's see this triangle is the same as that triangle. So we have to find the area of this triangle. Area of a triangle is half times the base times the height. Clearly the base is 7, the height is 24. So because it is this side and that side, I'll bring a factor of 2 outside. Now I have half times my base, that is 7, and then the height of the triangle is 24. It's 24. We are done with the two triangles, that is this side and then that side. Now let's consider BCDE. Clearly this is a rectangle, the base part. And what is the formula for finding a rectangle? That is the length times the breadth. So clearly we can say that that is 40 times 7. So plus 40 times 7. That is the base. Now let's also see the back. The back. What can we see? That one too is a rectangle. That is considering ABEF. It's a rectangle. It's going to be what? The length. So if this is 40, then this, that is BE, is also 40. So it's going to be 40 times 24. So plus 40 times 24 plus. We are not done. Now let's consider ACDF. ACDF is also a rectangle, and with the same approach, that is the length times the breadth. Clearly we know that the length is what? 40. But then the breadth is the AC that we found first, which is what? 25. So the last one will be what? 25 times 40. So we have to write it, that is 25 times 40. Now, clearly, let's see, this half will cancel out, the 2 will cancel out the half. So what do you have? 7 times 24. And when we use the calculator, 7 times 24 will give us, that is 168. Now, what is 40 times 7? Now, 40 times 7, that is 4, 7, that is 20, so that is 280. Now, we have 40 times 24, and this will give us, that is 960. And then we have 25 times 40. Using our calculator, we are going to get 1,000. Now, adding all, using the calculator, adding all, that is 168 plus 280 plus 160 plus 1,000. Using the calculator, we have, that is 2,408. And don't forget to add the units to it. That is the total surface area. Now, the third one is telling us we should find the volume of the prism. Third one, volume of the prism. Now, how do you find volume of the prism? Now, volume of the prism is cross-sectional area times the length. Cross-sectional area. Clearly, let's see. In this case, the cross-sectional area is this triangle. So it's going to be area of the triangle times, that is CD, the length. So clearly, you say that half times 7 times 24 times the 40. That is the volume of the cross-section. Okay? So our volume, the volume is cross-sectional area times the length. Now the cross-section is a triangle, and we know area of a triangle is half times the base. The base is 7, and then the height is 24, times the length. From the diagram, the length is 40. Clearly, 2 will go into itself 1, 2 will go into this, we have 12. So we have 7 times 12 times 40. From here, we have to use our calculator. And when we use our calculator, that is 12 times 7 times 4. This will give us, that is 3,360. Don't forget, for volume, it should be cubic. Don't forget to add your units to it. Now let's consider this example. It says that the diagram shows a solid prism of length 15 centimeters. So the length is 15 centimeters. Remember, this is not to scale. The cross section of the prism is the trapezium ABCD. So ABCD. We are being told ABCD is a trapezium. Now, hope you know how to find the area of a trapezium. That is half times sum of the power sides times the height. Now we are being told that if AB is 9, DC is 6 centimeters, and AD is 4 centimeters, you should calculate the total surface area of the prism. Now, for us to find the total surface area, it means that we should know the area of all the sides. So clearly, the trapezium, this side, is the same as the other side. So if I'm finding, I have to multiply, I have to only work for 1 and then multiply it by 2. Let me also say that probably this is A, B, C, D. So let's say this is E, F. Let's suppose that this is J, and then this is H. Clearly, if I want to find the area of CBJF, clearly CBJF is a rectangle. It's going to be length times the breadth. But in this case, I don't know CB. So it suffices me for us to find the CB. Now, for me to find the CB, let's see, from C, I can take a perpendicular line from C all the way to AB. So that is from C to AB. And this is 90 degrees. Now this is 4 centimeters. It means this one too is what? 4 centimeters. Now let's see, DC is 6 centimeters. It means that if this is P, it means that AP would also be 6 centimeters. What do you think will be here? This is 9. From A to B is 9. Clearly, this side will be 3 centimeters. 3 plus 6 giving us the 9. Now, we know that we have a right angle triangle. So we can use Pythagoras theorem to find CB. So considering the right angle triangle over there, and this is 90. So P here, C, and then B. By using, this is 4 centimeters, this is 3 centimeters. So using the Pythagoras theorem, we can say that CB square equal to, that is CP square plus PB square. Now what is CP? That is 4. So we have 4 square. What is PB? That is 3 square. Now 4 square is 16, 3 square is 9, so we are going to get our CB square to be equal to 25. We want to find CB, so the square will now come and be square root. And this is 5 centimeters. Now let's see, so we now know CB. We want to find the total surface area. So the area of the trapezium, so this side and that side are the same. So we have to multiply it by 2. So our total surface area, now 2. So we know that it's a trapezium, and since it's a trapezium, half times sum of the power sides. So that is DC and then AB, which is 6 half times sum of the power sides, so 6 plus 9, 6 plus 9, times the height. What is the height of the trapezium? That is 4. This is 4. This side, that is A, B, C, D. And at the other side is the same thing, so 2 times 8, plus. Now, area, let's find the area of CBJF. CBJF is a rectangle. And what is the formula? It is what? the length times the breadth. So here we can say that 15 times the CB, where the CB to be 5. So that is 15 times 5 plus. Now let's see the other. Let's see the top. Let's see the top. The top too is a rectangle. Now, if BJ is 15, then this side will be what? 15 centimeters. So for us to find CFED is going to be 6 times the 15. So clearly, this is going to be 6 times 15. That is the area of the top. Now, which one too is left? Now, let's also see the other side. That is DAHE. It is also a rectangle. Clearly, if this is 15, it means that this one too is 15 centimeters. So the area of it will be 4 times 15. You are not done. Now let's see the base. The base, that is ABGH. ABGH is a rectangle, and the area of a rectangle is the length times breadth. So here will be what? 9 times 15. Now, working out this, let's see, board mass, bracket first. This can cancel out this. Now what is 6 plus 9? That is 15 times 4 plus, now 15, now this 15 times 4, that is 60. 15 times 5, this is 75. 6 times 15, this will give us 90. 4 times 15, and this will give us, that is 60. 9 times 15, this will give us 135. Now, when you add all this, the answer will be 420. It is area, and the unit is centimeters, so this is centimeters square. You are allowed to use the calculator, so you can use the calculator to add all. Now let's consider this example. The diagram shows a hat used in storing grains, which is in the shape of a triangular prism mounted on a cuboid. So that is the STNMPO, and then the other side, which is not seen, it is a cuboid. And then we can see that we can see a triangle mounted on it. It says that if the dimensions are as shown in the diagram, calculate A, the volume of the hat. Looking at the diagram, you may think that it is a very difficult question, but it is one of the easiest questions that you can ever get. It says that we should find the volume. Now, volume is cross-sectional area times the length. Clearly, the cross-sectional area is made up of two things. That is what? A triangle and then a rectangle. So we find the area of the triangle plus the area of the rectangle. That is the area of the cross-section. Then times the length, which is 12. This is very easy. So first, let's try and see if we can sketch it. And you can see a sketch of it. So the first one says that we should find the volume. Now, volume is equal to cross-sectional area times the length, that is the volume of any prism. Now, what is a cross-section? The cross-section is made up of two things, a triangle and a rectangle. So you can say that that is area of the triangle plus area of the rectangle times the length. Now, what is the area of a triangle? We know it is what? Half times base times height. Clearly, look at it. MN is 8. So it means that ST is also 8, which is the base of the triangle. So it's going to be half times the base. The base is 8 times the height. What is the height? The height is given as 3 meters. This is the area of the triangle plus area of the rectangle. The rectangle, we know that the length is 8 and then the breadth is what? 6. So clearly it is going to be 8 times 6. This is 6. It means that this is also what? 6 meters. This is also what? 6 meters. Times the length. What is the length? It's the same as NO, which is 12. Again, volume, cross-sectional area times the length. This cross-section is made up of two things. That is a triangle and a rectangle. Now, 2 go into itself 1, 2 go into 8, that is 4. So you have 4 times 3, that is 12. What is 8 times 6? This is giving us 48 times 12. Board mass, bracket first. So what is 12 plus 48? This is giving us 60. And then we bring the length, which is 12. Clearly, our volume, which is 60 times 12, and this will give us 720 and then meters cube. 6 times 12 is 72, and then we add a 0 to it, which is 720 meters cube. That's very easy. Now, the second says that we should find the total external surface area. It is talking about the external, not the internal. The one that if you are standing outside, you would be able to see. So when you are outside, you wouldn't be able to see the base. It means that the base is not part, only the external. So our total surface area, that is the external. When it is external, we are supposed to find this. Clearly, let's see. We can see that this side is the same as the other side. Now, this side is made up of two things. That is a triangle and a rectangle. So I'll bring a factor of 2. So a factor of 2 outside. Now, area of the triangle, that is half, times the base. The base is 8. Times the height is 3. Plus, that is the triangle, plus the rectangle. What is the area of the rectangle? That is 8 times 6. So I'm done with this side and then that side. That is why I've brought a factor of 2. Now we are also left with the front side. The front side. Clearly, the front side is made up of 2 rectangles. That is rectangle RTPQ and then also TNOP. 2 rectangles. And this side too is the same as the back side. So I'll bring a factor of 2 outside, bring a bracket. Now this rectangle is going to be 12 times 6 plus this very side, this very rectangle, that is RTPQ. Now this is 12. It means that TP is also 12 meters. So it's going to be 12 times 5. Clearly, from here, what do you have? 2. Now, 2 go in Joseph 1, 2 go here, that is 4, 4, 3, we have 12. Now, 8 times 6 is giving us, that is 8, 6, 48. Plus 2, board mass, bracket first. So let's deal with the bracket. Now, what is 12 times 6? That is 12, 6, that is 72. Plus, now what is 12 times 5? This is 60. Now, board mass, bracket first. What is 12 plus 48? This is giving us 60. Now, what is bracket first? What is 72 plus 60? This is 2, and that will be 1, 3, 2. Now, what is 2 times 60? This is 120. Now, what is 2 times 132? This is 2, 6, 4. And clearly, when we add all, we are going to get 384 meters square. Why? It is area. So it should be 2, 2. Clearly, this is very easy. We can see that the total surface area, it is saying that the external, So we don't add the base, which is what? The 8 times 12. We don't add it to it. You have to note that it is saying that what? The external. Now let's consider finding the capacity, that is the volume of a cuboid. Now the volume of a cuboid, that is its capacity. How do you find it? We see that cross-sectional area times the length. So this is the cross-sectional area. In this we can see that this is the cross-sectional area. Now, so you can find the cross-sectional area and then we multiply it by the length. The cross-sectional area here, we can see that this is the breadth and then this is the height. So that is WH. And then we can add the L. You know the width is the same as the breadth. Now, it says that if the volume of a cuboid is 343 centimeter cube, you find the length of its side. Now, we know that volume, if it is a cuboid, is going to be length times breadth times the height. But in this case, all of them, the breadth and then the height, are all the same. You know, the breadth is the same as the height, which is the same as the length. So here we can see that L times L times L. And this is L to the power 3. Now what have we been given? We've been given V, which is 343 centimeter cube. Now, what again? We want to find L. So L is L cube. Clearly we've given V to be 343. So we have L to the power 3 to be 343. Now L will be cube root of 343. And cube root of 343, this is giving us 7. Or we have L to the power 3, 343. Now L to the power 3, 343 is this, we can be expressed as 7 to the power 3. Because the exponents are the same, we equate the base. This implies L equal to 7. So that is 7 centimeters. Total surface area of a cube is 24 centimeters squared. What is the volume of the cube? Now for a cube, the length, the breadth, and then the height are all the same. So here, if you have the length, breadth, and then the height. Now our total surface area, you know there will be a factor of 2 outside. So here we get LB plus LH plus BH. But in this case, L is equal to the breadth and is equal to the height. Therefore, our total surface area, 2 outside. So we have L times L plus L times L plus L times L. Now, we have 2 outside. L times L, that is L square, L square, L square. Now L square plus L square, that is 2L square plus L square, that is 3L square. So we have 2 times 3L square, that is L square plus L square plus L square. And this is equal to 6L square. That is our total surface area. Now, in this question, we are being told that the total surface area is 24 centimeter square. So we've been given our TSA to be 24 centimeter square. Now, we want to find the volume. Clearly, what is the TSA? That is 6L square equal to 24. We want to find L. So we divide by 6. 24 over 6. Now, since we're going 24, that is 4 times. So you have L square to be equal to 4. Clearly, we have L to be equal to square root of 4. And this is 2 centimeters. Or L square equal to 2 square, which is 4. Because the exponents are the same, we can say that L is equal to 2 centimeters. What do we want to find? Volume. Now, volume is L to the power 3. And this is what? 2 to the power 3. And this will give us 8 centimeter cube. That is volume of the cube given to us. Now this is a past question, but then this objective says that what is the length of an edge of a cube whose total surface area is x centimeters square and whose volume is x over 2 centimeters cube. Now this says that of a cube. Now we've been given the total surface area of a cube, and that is x centimeter square. Now for what is the total surface area of a cube? If the other side is L, we add it to 6L square equal to x. Now we can find L square. Clear from here, L square equal to x all over 6. So this is what my L square. Now it is saying that, and whose volume is x over 2. Now volume is giving us x over 2. Now how do you find volume of a cube? Volume of a cube is L times L times L. We have x over 2. Now what is L times L? L square times L equal to x over 2. Why am I leaving it this way? Clearly L square is what? X over 6. So in place of this L square, I'll put x over 6 over there. This implies that this L square, that is what? X over 6 times L equal to x over 2. I want to find L. Clearly, what's the LCM? 6. So I'll multiply here by 6. I'll also multiply here by 6. So 6 times x over 6 times L equal to 6 times, that is x over 2. Now this 6 will cancel that 6. Now 2 go here, 1, 2 go here, that is 3. So what do you have? You have xl equal to 3x. We want to find L, so we divide both sides by x. So xl over x equal to 3x all over x. This is cancelling out that, this is cancelling out that. Therefore, our length is 3 centimeters. The question says that we should find the length of the cube. So the length of the cube is 3 centimeters. Now let's see this question. This is a past question. The volume of a cuboid is 54 centimeter cube. If the length, width, and height of the cuboid are in the ratio 2:1:1 respectively, we should find its total surface area. Now, we are being given the ratio of the length, width, and then the height to be 2:1:1. Clearly, we can say that, we can say if h is x, then the W2 will be what? X. And then the length 2 will be what? 2x. Now we've been given the volume to be 54 centimeter cube. Now how do you find volume? That is L times W times H. And this is equal to what? 54. Now what is our L? That is 2x. What is our W? That is x. What is our height? That is x. And this is equal to what? 54. Now 2x times x, that is what? 2x squared times x, that is 2x to the power 3 equal to 54. This to the power 1, so we add all. Now I want to find x. So we can divide both sides by what is multiplying the x. So we have 2x cubed over 2 equal to 54 over 2. 27. So we have x to the power 3 equal to 27. So here clearly the cube becomes cube root 27, which implies that the x is equal to 3. Cube root. Now, or we have x to the power 3, 27. Here, x to the power 3, 3 to the power 3, which is 27. So the exponents are the same. What do? We equate the bases. This implies x is equal to 3. Therefore, the length is what? 2x. So the length will be 2 times 3, and this is 6 centimeters. The width is 3 centimeters, and then the height is also 3 centimeters. We want to find the total surface area. So the total surface area, you know, there will be what? A factor of 2 outside. So you are having LW plus LH plus WH. This is the total surface area. Now what is the L? L is 6. We have 6 times 3 plus L times H. That is 6 times 3 plus 3 times 3. Board mass, bracket first, 6 times 3, that is 18. 18 plus 9. Now to board mass, bracket first, what is 18 plus 18? That's 36. 36 plus 9, this is giving us 45. Now what is 2 times 45? This is 90, and the centimeters, so centimeter square. There's the total surface area. Now let's consider this. A container in the form of a cube of size 24 centimeters is 3/4 full. 3/4 full of water. How many liters of water does it hold? Now, volume. Now, with a cube, all the sides are the same. So if you want to find the volume, it is L to the power 3. That is L times L times L. But then we have been to this 3/4 full, so we have 3/4 times L to the power 3. Now, what is the side? The side is 24. Clearly, we have 3/4 times 24 to the power 3. We can say 24 times 24 times 24. Now, 4 will go into itself 1. 4 will go into 24. That is 6 times. Now, 3 times 6, that is 18. 18 times 24 times 24. And this will give us 10,368 centimeter cube. So the volume is 10,000, that's 368 centimeter cube. But then the question says that how many liters? So we have to convert this to liters. We know that 1 liter is equivalent to what? 1,000, that is 1,000 centimeter cube. Clearly, if we want to convert this to liters, we have to divide it by 1,000. So our volume will be equal to, that is 10,368 all over 1,000. We want to change it to liters, and this becomes 10.368, but this is in liters. Now let's consider this past question. A cube and a cuboid have the same volume. So the volume of the cube is the same as the volume of the cuboid. It says that the length of the cuboid is 3 centimeters greater. So this is the cube. We have to sketch a cube. All the sides are the same. So this is x, this x, the height too is x. All the sides are the same. Now it is saying that the length of the cuboid is 3 centimeters greater. So this is x. So the length is what? 3 centimeters greater. Means x plus 3 centimeter. Note that this one too centimeter. Now let's see. It says that the width 2 centimeters greater. So this is the width, that is 2 centimeters. That is plus 2 greater. And the height 3 centimeters smaller. Now the height is what? Of the cube is x. Now the cuboid, it is saying that 3 centimeters smaller. It means x minus 3. Now we are being told to find the length of the edge of the cube. What are we told? We are being told that a cube and a cuboid have the same volume. Same volume. It means that the volume of the cube should be equal to what? The volume of the cuboid. So since the cube and cuboid have the same volume, this implies that the volume of the cube should be equal to what? Volume of the cuboid. Now, for cube, we have to multiply all the sides. That is x times x times x. And then the volume of the cuboid will be what? That is x plus 2 times x plus 3 times x minus 3. Now, what would this give us? That is x to the power 3. Looking at it carefully, this is difference of two squares. So you have x plus 2. And this will be what? X squared minus 3 squared, which is 9. So you have x to the power 3 equal to x plus 2, x squared minus 9. We can expand, we can multiply out this by expansion. We have x squared minus 9 plus 2, x squared minus 9. We have x to the power 3. Now multiplying out, we have x to the power 3 minus 9x. Now this time this, plus 2x squared. 2 times 9, that is minus 18. We have x to the power 3. Now this can go and then join this. So we have x to the power 3 minus x to the power 3 minus 9x plus 2x squared minus 18 equal to 0. What can we see? Clearly this and this will cancel out. So we have 2x squared minus 9x minus 18 equal to 0. Now let's see. This is quadratic factorization. This is quadratic equation, and we have to factorize. Now we have to multiply the constant. That is 2 by 18. That will give us what? Negative 36. So two numbers, when you multiply, you get negative 36. When you add, we have to get negative 9. That is negative 12 and then positive 3. So we have 2x squared minus 12x plus 3. Negative 12 plus 3. X minus 18 equal to 0. Looking at these two, clearly 2x is common. So 2x. What do I have? X minus 6. Now if this 3 is common, and what do I have? X minus 6 equal to 0. X minus 6 is common. I have to factorize x minus 6 out. What is left? 2x plus 3 equal to 0. We are multiplying two things equal to 0. We have x minus 6 equal to 0, or 2x plus 3 equal to 0. Clearly, x is equal to 6, or here our x will be what? Negative 3 all over 2. The question says that we should find the length of the edge of the cube. Now, because we want to find the length is never negative. So we forgo the negative 3 over 2, and then we see that therefore x is equal to what? 6. Since x cannot be negative. Now the question is, we should find the length of the edge of the cube. Therefore, the length of the edge of the cube is 6 centimeters. I believe you've enjoyed the lesson. Very, very trivial lesson. Please make sure that you go through everything that we've done. If you don't understand, play back the video for better understanding. Thanks for watching.